Okay. If you have any doubt, difficulty in previous lecture or lectures before that, you can ask. Because today what we are going to do is look at some applications of what we have done. And maybe we'll solve few problems so that you get idea about what kind of questions we will ask in exam. So before that, if you want me to explain something which we have already done, last lecture was little heavy.
सर लास्ट लेक्चरची डायग्राम सकट एकदा थोडीशी रिव्हिजन झाली तर बरं होईल थोडं.
मी पाठवलं तुम्हाला लास्ट लेक्चरची डायग्राम पाठवली आणि पीडीएफ पण पाठवली.
बरं ठीक आहे.
त्याचे डिस्टन्सेस परत एकदा बघायचे आहेत का नवीन गोष्टी, कारण ते ऑलरेडी आहेत नोट्स मध्ये पण आहेत आणि तुमच्या नोटबुक मध्ये पण आहे. Sure. Okay. So we have learned Pythagoras theorem, and then we have a right angle triangle application. Application means we should have few more results ready with us related to Pythagoras theorem. So if we have a right angle here and if we put altitude A, B, C, D, side opposite to capital C is small c, side opposite to capital B is small b, side opposite to capital A is small a. Let us call this distance BD as x and DC as 1. So x plus y is a. And this is height of triangle H. Okay. So maybe you can try. First result is h square is equal to xy. Prove that h square is equal to x into 1. तुम्हाला डायग्राम काढून देऊ का?
नाही मी बघतो
मला काय
आता मला लिहून दे.
मला काही काम नाही.
नाही तसं नाही मी बघतो.
Small a BC, small c, small b, h a, x a, y a, इथे right angle आहे, ते पण right.
Thank you.
झालं ना?
काय करायचंय? सॉरी लेट जॉईन झालो.
Prove that x square is equal to xy. Okay. किती जणांचं झालं? How many of you finished? Classroom 2, 3, 4, 5, 6. Okay. Online. Very difficult to check. So just hold on. Let me do it. We can apply Pythagoras theorem to
Finish,
three
sir.
triangles. Good. There are three right angle triangles here, which we can apply Pythagoras theorem to. So c square is equal to h square plus x square. B square is equal to y square plus h square. Correct? And we can write a square. Okay, let us add them. So c square plus b square is equal to x square plus y square plus 2h square. However, c square plus b square is a square and a is x plus y. If we expand this bracket, we get x square plus y square plus 2xy is equal to x square plus y square plus 2h square. Therefore, xy is equal to h square. This is our first result. Altitude square is x into y. Result number 2. C square is equal to ax. Prove that c square is equal to ax.
चांगलं.
Okay. होय, नको होय, ठीक आहे असणार काय. ओके. हा येस. c square is equal to h square plus x square. But h square is equal to xy. Therefore, similarly, you can prove b square is equal to sorry, b square is equal to ya. Okay, b square is equal to ya is exactly same as c square is equal to ax. B square is equal to h square plus y square. Yeah. H square is xy. Last 1 upon h square is equal to 1 upon b square plus 1 upon c square. Ah. Hello. Good. So let us do it. Because we have got the 3 results with us now, we've already done. We just substitute h square by 1 upon xy. We don't know whether this is equal or not. Is equal to 1 upon b square, which is ay plus 1 upon ax. So we take LCM axy, numerator becomes x plus y, which is a upon axy. Question. Question. 1 upon, yes. So the method 1. Try to do it by method 2. This is method 1. Method 2. By one more method. Suppose we put this problem first and then the remaining 3 problems. Then it is going to be difficult without using the first. Yes. Okay, let us do it. Now we have a right angle and its altitude is available. Therefore, AH by 2 is equal to BC by 2 delta. Area of triangle is A into H base into height upon 2, which is also product of sides. Right angle triangle easy to find area, which implies AH is equal to BC. So we consider A square H square is equal to B square C square. And we substitute A square is equal to B square plus C square. Therefore, 1 upon H square is equal to B square plus C square upon B square C square, which is 1 upon B square plus 1 upon C square. All these four results put together, they are called a complete Pythagoras theorem. So if these four results are remembered along with original Pythagoras theorem, then you save a lot of time in solving problems because these are standard things. Okay, so this was one part. Second part is converse of Pythagoras theorem. Now, suppose why do we require to write this is suppose I give you three sides like 3 upon root 2, 3 upon root
सर
2.
स्क्रीन पे नहीं दिख रहा सर.
लिख रहा हूं. Use it.
Board.
Yes, I am writing on the board only.
Okay. Now, sir, अब display हुआ. Yes.
Okay. And then 9 by 4, 9 by 4, 18 by 4, 9 by 2, 9 by 2, 18 by 2, 3. Suppose three sides of the triangle are 3 upon root 2, 3 upon root 2 and 3. Then it is a right angle triangle. Isosceles right angle triangle. Why? Because 45, 45, 90 we studied. If hypotenuse is say 2 root 2, then the sides are 2 and 2. X, X, X root 2. Because of Pythagoras theorem. है ना? So if now the sides are given, sides of any triangle are given, then we should be able to conclude that this is a right angle triangle. That means we are not using Pythagoras, we are using converse of Pythagoras. The sides are such. So statement, in triangle ABC, sides A comma B comma C are such that A square plus B square is equal to C square, then triangle ABC is right angle triangle right angled at C. This is the statement of Pythagoras, converse of Pythagoras theorem. And surprisingly, more than 300 proofs are there for Pythagoras theorem, and there is only one proof for converse. Anybody aware of any proof of converse of Pythagoras theorem? Now we know it is going to be, it is going to be right angle triangle. Intuitively, it is very easy to understand that if the sides are behaving like A square plus B square is equal to C square, then the triangle must be right angle triangle. Intuitively correct, but they don't accept intuition, they want proof. So how do we go about it? Let us write proof. Proof. What we have with us is triangle ABC. Deliberately, I am not drawing it right angle. So this is C, this is A, this is B. Suppose we have been given in triangle ABC, sides are C, B, and A, such that their algebraic relationship is A square plus B square is equal to C square. So we have this triangle with us. And now we have to prove that this angle is 90 degrees. Okay, so construction. Let QR equals a small a. We can construct a segment QR which is of distance small a. Let PR, let PR QR equal to small a, PR equal to small b, and measure angle PQR equal to 90. This is what we will construct. This is P, this is 90, and this is small b. And join
Angle
Q.
PRQ is 90, right?
PRQ is 90. Join PQ. Now we have constructed right angle triangle. Therefore, this side PQ. So PQ is equal to square root of a square plus b square by Pythagoras theorem. We have proved that, therefore we can use Pythagoras theorem to prove converse. PQ is equal to radical a square plus b square, square root of a square plus b square. However, a square plus b square given a square plus b square is equal to c square. Therefore, PQ is equal to root c square, which is equal to c. Right? Therefore, triangle ABC is congruent with triangle PQR by SSS. And therefore, measure angle PRQ is equal to measure angle ACB equal to 90. So you construct another triangle whose measures are the ones which you want and use given information to show that the third side is equal to your given triangle third side, and therefore these two triangles are congruent by SSS, and hence corresponding angles must be congruent. Hence this angle is equal to this angle, and it was 90 here, therefore it should be 90 there. This is converse. Only one proof. Yes.
So that means I can use.
Yes, because it is proved. Yes.
So can they do this by contradiction?
This is more or less contradiction only.
It's a different person. That's
Yeah, you. This is not 90, so drop 90.
That says, let's say C, if it is 90, what I can do is I'm taking AC and BC. I'm holding point C, and then if I stretch it along AC, then that becomes an acute angle.
So you want here 90 degree, right? So it is going to be a different line.
I can make it acute or obtuse.
अरे अर्णव
Then I will get AC plus C square at the other side. A square plus B square. C square or less than 6.
AC to be copied here. No. Understood. Understood. What you are saying, but there are two variables.
Yeah.
Yeah, but then you have to use this B's original triangles B, and you are proving contradiction. So you have to have A dash here on this ray, and A dash is equal to this A dash C is equal to B.
Not. I'm stretching C along AC.
You are stretching C this way, this side. Okay.
And first, let's say then it need not become 90. Right? So if it is acute. If it is acute, I will get A square plus B square as greater than C square. If I push it down,
But then that is intuition. It is intuition. Yeah. So
Algebra is if I take an extra.
I mean, you try to write it, but it is going to be complicated, and there will be some flaw. There will be some flaw. I thought you are saying, let us, if possible, this is not 90, so you can always draw 90.
If it is not, when you take one case, I get a contradiction.
No, acute where here?
Yes.
Okay, then
Then I take obtuse, I get still a contradiction. Because it's okay to use Pythagoras theorem.
yes.
So for acute and obtuse, I get a contradiction. That A square plus B square will be either greater than 6 or less than 6. So if I'm getting contradiction in all the cases, then the only alternative is A square to B.
But then why a square plus b square if it is acute? No. If it is acute, why is a square plus b square less than c square?
That, let's say a square plus b square is not 6.
Is not c square. No, we don't. I mean, it is given. Why are you assuming which is not true? It is given.
Contradiction. When it is not.
So okay, so when you are saying a square plus b square is not c square, that means you are saying that triangle must be acute or obtuse without any support.
So what I'm saying is, if I take it as acute,
Yeah,
I get.
then it will be less than a square plus b square will be greater than c square. But then, I mean, that is because we have a cosine rule with us, which is
Sir,
Given that says that it's not.
yes.
If I take it as acute, I'm getting a square plus b square is greater than 6. But the given condition.
But then that argument doesn't have mathematical support.
By taking an extra variable.
Then it is going to be inward.
So if it is obtuse, then I get a square plus b square is less than c square. So the given condition.
Yes. Correct. Yes. But yeah, so you will have to support that statement that if it is acute, it is greater. If it is obtuse, it is smaller.
Yes.
Yes. Correct. Yes, somebody was saying online something. Okay. So now if you happen to get three sides of any triangle which behave like this, x root 2x or x 2x root 3x. Suppose three sides are in this proportion. Then also it is going to be a right angle triangle. Okay, in this case it is 30, 60, 90. In that case it was 45, 45, 90. But you can always have sides, not necessarily 30, 60, 90 or 45, 45, 90. You can always have A, B, C such that I can have A is equal to 5, B is equal to 7, 7 49 आणि 25, 49 आणि 25 54 74. बरोबर ना? 49 25 हा 74. If I have sides like this, still it is a right angle triangle. Not special, but right angle. So we are free to use converse because we have proved it now. Good. Next. Triangle ABC is equilateral.
Question here.
Yeah.
If special triangle dimensions दिले असतील, तर can we prove other way around की looking at a dimension that is a special right angle triangle?
Yes, if A square plus B square is equal to C square, then it is right angle. And if the sides are in the proportion 1:2, 2:2, 1:2 root 3, then it is 30, 60, 90. If they are 1 root 2 S21, S21, then 45, 45, 90. If the sides are in good proportion, then we can identify the triangle. So this is very important because I will give you sides and ask some angle of that triangle, which is difficult to connect otherwise. Using sides, unless you know trigonometry, you cannot connect with angles, measures of angles. But if it is a special triangle, that too using converse of Pythagoras theorem, you can arrive at different angles.
My question was, see, for example, 2:1 root 3 जर आपल्याला दिलंय dimensions, we haven't proved कि it is other way around. We have proved if it is 30, 60, 90, then the dimensions will be in this ratio. But
Yes.
if the ratio is given, the angles are 30, 60, 30 and 60. That we haven't proved.
Yeah, I mean, once we say that A square plus B square is equal to C square, it is a right angle triangle.
Right.
And after that, we can observe that there is one side which is half of the hypotenuse. So we
Okay.
get the converse statement
Got
over
it.
there, we get that they are 30 and 60. We can complete equilateral
got it.
triangle there and get the 30-60.
Got it. Okay.
Yes. Triangle ABC is equilateral with side equal to 10. Find ABC, area of triangle ABC. Simple. Hello? Very good. So 25√3 is the answer. And if the side is small x or a, then area of equilateral triangle is √3/4 very useful formula. हा कोणाला एक्सप्लेनेशन हवं असेल तर सांगतो, but it is easy.
Sir,
If you drop
what is-
perpendicular, you have 30, 60, 90.
Sir, why 25√3? So 5√3 upon 2.
बरोबर आहे ना?
We-
100 भागिले 4, 25. बरोबर.
Sir, if we apply the formula, then is acha, sorry. It's sorry.
So this is a/2. आणि काय करतो आपण? एरिया. We want height basically. Base is a. Height is a√3/2. So delta ABC, area of ABC is equal to A into a√3/2 upon 2, which is √3/4 a square. Good.
सर ही हाईट कशी आली ते नाही मला कळलं.
30, 60, 90. This triangle is 30, 60, 90 because you are dropping perpendicular, cutting the equilateral triangle in two parts. And in 30, 60, 90, we have said if hypotenuse is A, side opposite to 30 is a/2, and side opposite to 60 is √3/2 times A.
Hmm.
Okay. Next question. In quadrilateral ABCD, measure angle ADC is equal to 90. AB is equal to 28. BC is equal to 25. CD is equal to 8. DA is equal to 15. Find area ABCD. आज मला कमी आहे काम बोलायचं नाही याच्याशी. Eleven standard, 10 standard third year. I mean 3-year batch 10 standard. नाही नाही नाही.
Got it, sir.
Good.
Done, sir.
Okay. So numerical answer good. Good numerical answer. किती उत्तर आहे?
270.
270.
Yes, sir. 270.
Okay. So what is this information? There is one angle which is 90, which is given. 815 D A C. So you can complete this and get this side, which is 17. And then you have CB is greater than so CB is 25. Sorry. अरे उलटलेलं मी थांबा. ओके हे बरोबर होतं. सी इथे याला सी म्हणायचं आणि याला ए म्हणायचं. आता ए बी मोठा आहे बरं ए बी मोठा आहे. सो दिस इज 28, दिस इज 25 and this is 70. So we have to use Heron's formula here to find out area of that bigger triangle and right angle triangle. So this is easy. So total area is good. You are doing good. थोडं बघूया आता डिफिकल्टी वाढवतो जरा थांबा. Yes.
एबीसी ची एरिया कशी काढली मला नाही कळलं.
एबीसी तिन्ही साइड्स माहिती आहेत. सो हेरॉन्स फॉर्म्युला
ओके.
in right angle triangle ABC. Okay, let me draw a diagram so that it will be fast. In right angle triangle ABC, right angle at A, AB 15, AC 20, 15, 20. AD is perpendicular to BC. DE is perpendicular to AC. Find DE. AB is 15, AC is 20. Find DE.
Sir,
Yes. नाही दिसत तो बॅकग्राऊंडला येते ते चित्र.
ओके ठीक आहे सर. एक मिनिट हा.
बॅकग्राऊंड दिसते फक्त. वही दिसतच नाही.
एक मिनिट सर, मी व्हर्च्युअल बॅकग्राऊंड हे करते.
ओके 6 आन्सर. आन्सर इज 6.
9.6.
9.6 सर ऍक्च्युली.
Okay. 9.6.
येस सर.
You can use complete Pythagoras theorem. We have done that just now. So this is 9.6.
Correct.
Or maybe 2-3 times Pythagoras theorem. You will get it. Easy. Next problem. ABC is isosceles. AB is equal to AC. P is any point on BC. PM PN are perpendiculars. Q is some other point on BC. QR and QS. Q is other point on BC. QR and QS are perpendiculars on AB and AC respectively. Prove that PM plus PN is equal to QR plus QS.
see this.
Done, sir.
Good.
Done, sir.
Good. Okay, now maybe I will give you a hint. Now you will get it. Measuring the same area in two different ways. One using green triangles, one using orange triangles. The triangle is same, isosceles triangle. You make two parts in two different ways, but the area of both of them will be same. Total area is going to be equal. But your methods of finding will be different, therefore an identity. Area will go away from calculations, only the identity will remain. And the identity is PM plus PN is equal to QR plus QS. Now, area of triangle APB is AB into PM upon 2 plus area of triangle APC is AC into PN upon 2. However, AB is equal to AC. So, this is equal to, if we consider orange triangles, AQB, it will be AB plus QR, AB into QR upon 2 plus AC into QS upon 2. This is area of ABC. This is also area of ABC. And you will find that AB is equal to AC 2 everywhere, getting cancelled. PM plus PN is equal to QR plus QS. Right? So this is difficult because you have to draw a segment which is not there, which is deleted. Unless you construct that, it is not going to give you any result anywhere. I mean, because we have a emphasis on Pythagoras theorem, there are a couple of right angles here. If you go behind Pythagoras, it is not going to happen. We have to go behind area. Next, we have a regular pentagon. All 5 sides equal, all 5 angles equal. A, B, C, D, E. We join all the diagonals. And hence we end up getting P Q R S T, pentagon in between. Everything is symmetric, regular. All the sides are equal. This side is equal to 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 this. All angles are equal. Okay. So suppose area of ASR is equal to X and area of ARB is equal to Y. Find area of PQRST in terms of X and Y. झालंय कोणाचं? ओके. Should I wait or should we discuss? Okay. Five more minutes. 8:31. Okay, I will not solve it completely. I will try to help you out. On the first day, we have found out the sum of internal angles of pentagon, which is 540. And all angles are equal. There are 5 internal angles. So each angle is 540 upon 5, which is 108. So angle here, angle interior angle. So this angle is 108. Everywhere it is 108. This is first observation. Correct? Okay. Then this is isosceles triangle. ABC triangle ABC is isosceles. Therefore, we can find out these base angles. Because vertex angle is 180, 72 remaining should be distributed equally. Therefore, this is 36, this is 36, and similar looking, all are 36. Right? And total 108, out of which these two are 36, 36. Therefore, third is also 36. Right? This is first information. Therefore, triangle ABC is congruent to triangle ATC. ABC is congruent to ATC by ASA. AC is a common side and both the base angles are 36, 36. Therefore, these two triangles are congruent. Okay, if this much information is available, then this triangle area is Y, this triangle area is also Y, and this triangle area is X. This is Y, this is Y, this is X, and this is X, and this is also X. Therefore, pentagon is 2y plus x minus 2x. PQRST is equal to area of ABC and area of ATC will be equal. Area of ABC is 2y plus x and area of ATC is also that much, out of which 2x should be removed. Two y minus x is the area of pentagon. ठीक आहे. जर काय कळलं नसलं तर विचारा. In fact, you can find out all the different properties here. I mean, this is 72, this is 72, this is 72. Yes,
Can we please repeat the PQRST is equal to 2y plus x
yeah.
minus 2x?
Have you understood this statement?
Yes, sir.
Therefore, area of ABC is equal to area of ATC because they are congruent triangles.
Correct.
ABC is y plus x plus y. And area of ATC is x plus PQRST plus x. Therefore, PQRST is equal to so this is a very symmetric figure, and we can prove that PQRST is also a regular pentagon.
तर BRQ triangle ची X कशी हे केली तुम्ही म्हणजे
Everything is symmetric. So these five triangles are going to be congruent. I mean, we have not proved it, but
Okay.
we can prove it.
हा सिमेट्री वाईज आहे पण we haven't proved it. Okay, that's what I was okay.
No, we can write the proof. Very, very easy. I mean, we have got now this side is equal to this because of isosceles.
Right.
Lot of information is flowing.
It can be proved, yeah.
Sir,
काय काय? Yes, but we require trigonometry for because these 36, 72, 108 are not friendly angles unless we have. Yes,
Hello, sir.
yes.
Can we also use that if base is same and vertices is same, then the area of the triangle is same? So, for example, in triangle ARB and in triangle ARE, both the area will be same because the base AB and AE is same and the vertex is R. So from there we'll have the same height.
Slow. I mean, which two triangle area you want to be equal, make equal?
ARB and ARE.
ARB and ARE, they are not going to be equal. ARE, you mean, na, this triangle.
Yes.
And this triangle. They will not be equal.
Okay.
In fact, blue is y plus x and white is only y.
Yeah, got it.
ठीक है? Okay. Okay, let me ask you a different question. ABCD is a square. And BCE is equivalent. BCE is equivalent. And ABCD is a square. Find, okay, if the side of P is equal to 10, find DE. There, be there. Correct. Very good. झालं? हा? नाही इंटिजर Yes, answer is very bad. Yeah.
Sir, can we get it with the diagonal of pentagon? Sorry. Right, sir.
Can we get it?
With the diagonal of pentagon?
This is new problem.
Okay, sir. I know. Sir, all the sides are equal na, and it is pentagon. So
Yes.
it's like-
Yes, it is a
Yes,
pentagon,
yes, sir.
but it is not regular pentagon.
Sir, all sides are equal now, but yeah.
All sides are
Angles
equal, but
different. Angles are
all
different.
angles are
Yes,
not
sir.
same.
Sorry, sir.
Okay, so this is a problem where maybe you have to do construction, go out, draw perpendicular. This is 10. Everywhere it is 10. Okay, this is 60. This is 90. Therefore, this is 30. This is 90. Therefore, suppose this point is P, this is 5. This is 5 root 3. So we want to find out DE. In this right angle triangle, we should use Pythagoras. So dP square plus PE square is equal to DE square. So DE square is equal to 10 plus 5 root 3 is dP square plus PE 5 square is equal to DE. This is what is DE square. So 100 plus 75 plus 100 root 3 plus 25 is equal to DE square. 200 plus 100. So 100 into 2 plus root 3 is equal to DE square. Therefore, DE is equal to 10 root 2 plus root 3. You can do, instead of this construction, you can join this and consider right angle triangle QDE. You'll get the same result. This was the problem. Koteshwar sir's son, Siddharth, is a international silver medalist, right? silver medalist in mathematics. And when he was in sixth standard, he came to institute for interview and test. This was the problem which the entire batch did not solve. No. The batch which was at that time along with Siddharth, and only one student solved this problem was Siddharth. And then he was picked up for a special Olympiad training. Prakash sir taught him mathematics up to MSc. When he was in ninth or 10th, ninth standard, he finished MSc mathematics and eventually got medal for the country. Now he is in Chennai Mathematical Institute, first year of BSc. Na? What degree they provide? BSc. BSc Maths. Computers. Yes. That is why I thought I will give you this problem today. He's your son, so you will solve it, no doubt. Okay, one more problem. We have 12 minutes. Put again the PDF. In triangle ABC, angle C is 90. AC is 24. In circle touches BCCA AB at DEF. BC touches at D, CA touches at E, and it touches AB at F. If in radius is 3, find BD. CA is 24. What is the answer? 4. Now this can be done in two ways. One is, now this total distance is 24 and in radius is 3. We draw perpendiculars. So this is a square. 3 angles 90, therefore fourth is also 90. And two adjacent sides are equal. Otherwise it could be rectangle, but 90, 90, 90, 90 and two adjacent sides equal. Therefore this IDCE is a square. Therefore C is 3, DC is 3. So AE is 21. Therefore AF is also 21. So only thing which we don't know is BD. Let us say BD is X. Then BF is also X. So now we have got all the sides of triangle in terms of X. Therefore applying Pythagoras you can find out value of X. Second method is delta is R into S. So total semi-perimeter we can find out, and area 24 into X plus 3 upon 2. If we count it that way also, we will get X is equal to 4. Okay. Maybe I will send you a few more problems like this on group to solve as a practice.
second method परत एकदा repeat करते का please?
Second method. S 2S perimeter is equal to 24 plus 21 plus X plus 3 plus X, which is equal to 48 plus 2X. Therefore S is equal to X plus 24, semi-perimeter. Therefore area is equal to X plus 24 into in radius 3, which is also equal to CA into CB upon 2, which is equal to 24 into X plus 3 upon 2. This is the relation we have. X plus 24 into 3, X plus 24 into 3 is equal to 12 into X plus. So if you solve, you'll get X is equal to 4. ठीक है. ओके, थँक्यू व्हेरी मच. आज सुद्धा 50+ लोक होते. चांगली गोष्ट आहे. First 8 lectures over. We will have exam and then we will decide what to do after that. ठीक आहे. ऑल द बेस्ट. सगळ्यांनी या परीक्षेला देते. MIT मी डिटेल्स पाठवतो सगळे, टायमिंग, व्हेन्यू, गुगल मॅप सगळं. येस. Which one?
Say,
Ah.
I mean, if I assume that it is not 90, case 1, I'll test the acute. Because this is acute, I can drop a perpendicular.
Correct.
Then I'll get A square plus B square C square. But it is given.
Correct.
So contradiction.
Correct.
Then I say C is obtuse. Again, I get a contradiction.
Correct.
This
Contradiction method, yes. Right, it must be 90. Okay, thank you. See you. Ending the meeting.
Thank you, sir.
मंगळवारी क्लास नाही आता परीक्षेपर्यंत काय नाही क्लास. हो नाही, आता 20 तारखेपर्यंत अभ्यास.
PDF करून पाठवली.
हो
दिसत नाही एवढं.
सर
पाठवतो.
exam ची date काय असेल?
Sir, problems practice
प्रॅक्टिस प्रॉब्लेम्स पाठवतो.
आणि so that should be enough for the practice, or can we practice from somewhere else too?
Yes, you can practice. I think I will send you the number of problems will be so much that you will not be able to solve all of them.
Okay.
त्याच्यावर पण चालू आहे.
Sir, when is the exam?
याच्यावर का त्याच्यावर?
त्याच्यावर जे शिकवलंय त्याच्यावर परीक्षा.
Sir, when is the exam?
And the problems that you're giving are not what we are discussing in the class, right? So
No, we discussed everything required for
No,
solving.
the problems that you're giving on the group are also
On the group, they are different problems. Yes,
correct.
they are for your general practice.
Okay.
You will have problems in exam based on what theory we have discussed in last 8 lectures.
Okay.
Thank you.
So then there is no class in the next week, sir?
No class next week till 20th April. There is no class, and we will find out what to do afterwards after the exam result.
Okay, sir. Okay.
Today, bring this one, please.
Thank you. Ending the meeting.
पेपर सोपा ठेवा सर.
Oh.